right, our final example under the I do, you do concept is example 7. So I'm going to do one more example with you, and then you will do the even examples 8, 6, and then the 2 on the front, 4 and 2 as well. So we want to look at the original equation. Notice that this is not in standard form. We do know it's a hyperbola though because of the subtraction, and so we're going to know that we need that hyperbola to equal 1. So we would divide everything respectively by 432 in this case. And when I simplify 12 and 432 on my calculator, I'm going to get 1 over 36. Or 3 and 432, I'm going to get 1 over 144. If you're having any trouble with that calculator connection, again, reach out independently, and Ms. Olson can kind of shoot you a quick extra video if need be. So then the next thing that we tend to look at is what is our direction of opening, where's our center. Those are some easy starting points, and what kind of hyperbola is it. Again, we know it's a hyperbola because we have a subtraction. So the y squared is first, which means it's going to open down and up, which makes it a vertical hyperbola. So again, we want to get used to naming this, even though it's not required in this set of notes. It will be something that you see as you move forward in the homeworks, as well as within, you know, all of the shapes you're going to need to name in their specific name. So there are no shifts on the x squared or y squareds today, and so we're going to keep that center at 0, 0 where it has been all day. As we're identifying vertices and covertices, remembering not to list the covertices, but only use them in the graph, one of the things we want to be mindful of is whether the a squared or b squared is first. So again, if we need to, at any point, we can always pause for right now, and remember that the a is always positive, so it's first. And that's different because when it was an ellipse, that was a different rule. So we just want to make sure that we're paying attention to what world we're living in. We're currently in a hyperbola world. So a squared is 144, which makes a plus or minus 12. That means the b squared will be 36, and making b plus or minus 6. So as I go to make my graph, you'll notice that Ms. Olson actually kind of already planned ahead by giving you a slightly taller grid space. Usually on a quiz or a test, I would not be giving you that hint along the way as to what direction it opened, so just be mindful of that. So as I look here, I want to count and see if I can get 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I can. Hopefully I can on the bottom. 1, 2, 3, 4. All right. So I do have those vertices that are in place. I like to label them as just my reminder which way things will open. So as I go for my co-vertices, I want to go 6, and then remember again, it's underneath the x, which is already your hint of which way to count those values. I'm going to use that open circle to indicate that those are not real points on the graph. Then I'm going to connect my vertices and co-vertices with my guide box. If you make this guide box with your ruler and kind of trace along that for the dashed lines, probably even increases the accuracy of your asymptote locations. You notice sometimes Ms. Olson's had to kind of make sure that she's hitting those asymptotes through the center. That's less of a problem when you are using a ruler for the actual placement of the asymptotes along the way. We'll graph those asymptotes. And this is going to be a little longer, so you want to make sure that you're taking care to hit all 3 places, the 2 corners of the diagonal and the center. And using our dashed line, do one more, try and speed this one up just a smidge since this is our last example. Hopefully you're starting to get the hang of this. Alright, then we need to graph the hyperbola itself, because so far we don't have that. So we want to look to our vertices, and it opens up and down, so we want to hug the asymptote. Now we want to make sure that it does not go inside the guide box, but we do also want it to look like it's one big smooth curve here. So if you get feedback as you turn in assignments or e-slips, if Ms. Olson is commenting on that for you, you want to make sure that you're looking to improve it, because it would be something that would be a point deduction. Alright, so we have the final two components are still our foci and asymptotes. And so with foci, we want to start with our focal relationship, and Ms. Olson will remind you for the last time in these notes that you always want to make sure that you're writing that relationship and that you're comparing the original equation as subtraction, which means that at the moment I need to make that adjustment in my focal relationship because I want this sign for the focal relationship not to match the original equation. Alright, so we have a squared was first, 144, b squared is second. So as we simplify this piece, you'll get a value of 180. Now, if you were to leave it as square root of 180, that's acceptable, but it's best if you're breaking it down. Okay, so you have the positive and the negative. Since this one is not one that you do all the time, I'll kind of show you the steps. You have square root of 36 and square root of 5, because 36 times 5 equals 180. 36 being the largest perfect square that goes in there, and that's how I simplify to my 6 root 5. Now the reason that I know that it goes under the y coordinate though, is again just a reminder that since this opens up or down, that value needs to be inside this branch, and the only way to get in there is to go vertically. So it's going to affect the y change. You're going to move up 6 root 5 from 0, and you're going to move down 6 root 5 from 0. Now, one of the reasons that Ms. Olson has told you that it's okay to think about using square root of 180 is you might know that the square root of 144 is 12, and so you know this is a little bit bigger than 12. And so if you were to count something big, you're like, okay, cool, it's where it needs to be. And so this number of square root of 180 is probably more meaningful without a calculator to estimating that you have the correct value here. Alright, last but not least are our asymptote equations. So I'm going to slide this up a little bit, making sure that hopefully you can see that final portion. So we're going to start again with our point slope form. Even though our center's at 0, 0, it's never a bad idea, because knowing tomorrow we're going to start to use more complicated centers, it won't hurt for us to have a good technique and practice. So when we get to the slope, we want to count from the graph. So we're going to count up 12, and we're going to count over 6. Now 12 over 6 reduces, and so you'll see here that we've listed both 12 over 6 and 2. This is most definitely the way we would want to see it in the final answer. I don't actually really need to see it as 12 over 6, unless you're nervous about it, because I certainly think our ability to count that is going to be pretty strong in most cases. Alright, make sure that you do complete the even examples and check them against the answer key, and then proceed to doing the homework. Have a great day.